Hello everyone, I'm Xu Wang, an assistant professor at the University of Michigan. I'll be presenting our paper today, which I collaborated with Caroline Rose and Ken Kittinger. Large numbers of people are seeking higher education and professional development from different sources. For all of these educational service providers, one challenge to meet the demand is to scale these educational opportunities while maintaining or improving their quality. However, maximizing system scalability and quality are sometimes at odds. For example, in one-on-one tutoring, students may receive individualized feedback. However, this doesn't easily scale. In contrast, MOOC lecture videos are easily scalable, but they do not provide interactive forms of learning by doing, which was found to produce higher quality learning. In this paper, we show an example where scale and quality may be achieved at the same time for online learning design. When giving formative assessments in classes, instructors are often faced with the decision of giving multiple choice or open-ended questions. Multiple choice questions can be automatically graded, thus easily scalable to thousands of students. However, one might argue that using MCQ is making a quality sacrifice. One sensible argument from instructors is, since recognition is easier than recall, MCQs are easier than open-ended questions, thus do not exercise the same level of thinking. In this paper, we provide both evidence for the prevalence of such beliefs and evidence for questioning these beliefs as they mismatch student data. To surface the prevalence of such beliefs, we did an instructor survey with 22 HCI professors from 9 institutions across 3 countries. They prefer to give open-ended tasks over MCQs for reasons such as recognition is easier than recall and that open-ended teaches critical thinking whereas MCQs do not. We then ran a student-facing experiment to validate the instructor beliefs. We designed pairs of matched MCQ and open-ended questions and compared student performance between the 2 question formats. An example matched pair looks like this. Both formats share the question stem, and the open-ended format invites an answer, whereas the multiple choice format gives several options. We designed 18 pairs of questions on popular UX skills, and 178 students answered them in exams. The result is quite surprising. The student data suggests that matched open-ended and multiple choice questions are of similar difficulty. And for some questions, the multiple choice version is even harder. However, when we give the same pairs of questions to instructors to predict, most of them thought open-ended to be harder. To further unpack why the principle recognition is easier than recall does not hold here, let's look at the cognitive processes students may engage in. When they answer the open-ended question, they will both generate candidate solutions and evaluate them. But when answering multiple choice questions, they don't need to generate, they only need to evaluate whether each candidate solution is good or not. Student data suggests that for a lot of problem-solving processes, the evaluation effort required is quite significant, and the generation effort required is relatively smaller. This further suggests in some problem-solving, evaluation is a key and critical thinking process which can be exercised through multiple choice questions in a scalable way. I will summarize the major takeaways of our work. First, we provide empirical evidence that for at least some domains where evaluation effort required is more significant than generation effort, online learning can benefit from the scaling advantages of evaluation type exercises, for example, multiple choice questions, without sacrificing and perhaps gaining learning quality. And second, we observe that instructor prediction of question difficulty do not align with student performance. This is another case that suggests expert blind spots exist. And well-designed, low-effort experimental comparisons help experts make more accurate and nuanced instructional decisions and design. To further improve instructional design processes, my group is continuing working on AI-augmented instructional design, in which we explore human-AI partnership to support educational content creation. Thanks for listening, and please check out our paper.